Okay, welcome back friends to TCT Lab, and for obvious reasons I am Mr. TCT. Well, in today's video we are going to be talking about linear regression. We are going to develop a model, right? A machine learning model that is going to predict linear regression in graphs. So first of all, what is linear regression? Well, linear regression is a statistical method to model a relationship between variables by fitting a straight line, that is the plane, right, to data and predicting dependent variables, that is the outcome from one or more independent variables, that is the predictors, using the least squares, right, and to find the best fit line that minimizes prediction errors. So that's basically it, and it's used widely for forecasting and understanding trends in fields from, let me say, economics to machine learning. And for in our case here, we are going to be using in fact this is machine learning. So those who are interested in machine learning fundamentals and also C programming, well, this video is for you. Okay, so without any further ado, we'll dive in. So actually we are going to create a model using C language. Well, I want to show you the simulation here, and well, we're not going to be developing this UI. We are going to be doing it in the terminal. We are going to develop the terminal version of it. Maybe later on in another video we'll develop this UI, this beautiful GUI, right, to simulate how it works. But for now, let me just demonstrate how for example, if I have a point here and I have another one, let me say here, here. You see what I get, seeing what is happening. Like, I'm trying to find a equation on the line, and then this green line is trying to go to the best fit of the based on the points the user plots, right? So we're going to be developing a model that will be predicting the best fit and come out with the equation of a line like this. So you see that it's trying to align into the, like, in the middle, right? It's trying to the best fit. So this is basically a simulation of it, and we are going to be developing from scratch using C, and our first model is going to be just in the terminal. Now later on, for those of you who are interested to see how this is developed, like this UI, well, then just comment below. Actually, this is a game engine developed by my friend. Big thanks to him, Amaken Morel. He developed this engine for gaming using C programming, but it's actually used in 3D 2D rendering, right? So you can also use it for this purpose. So in today's video we are going to focus only on the terminal application of it. Now in the next video, based on your comments, we may now program this other version to show the graphical simulation of it, right, using the Gamma engine. Well, for those of you who are interested, I'm going to provide the GitHub link for Gamma engine in the video below, and also the project, the GitHub repo. Okay, so without any further ado, I'm going to dive into my into the coding. Well, I think I should open my folder. I forgot to do this before recording. I was supposed to create a folder. Okay, I think let me create a file, a C file. I'm just going to say main.c, and now if I go back into my sublatex, I should see the main.c file. Okay, here that's where we are going to be doing the coding, right? So the first thing we are going to do is to include our variables, our header files as usual. So I'm going to say #include, right? I'm going to say stdio.h. so this stdio.h is responsible for the input and output functions, right? Now I'm going to say again #include math.h. and this math.h we are going to use it for our mathematical functions like the fabs, right, which is for absolute value, so to get a non-negative number. Okay, so now we have to include our main function. So int main, I'm going to say return 0. Okay, now here we can write our main logic. Everything goes in here. Okay, so the first thing we are going to do is to declare our variables. So I'm going to say size I for the counter, like is going to be responsible for the loop counter, right? Now comma, I'm going to have train size because the default value is going to be 1. Now this train size is going to be the number of training data points, that is, and we are initializing to 1 as default. Okay, so after that we are going to have some print off message, like some welcome messages, and also input data from the user. So first of all, we need to print the message on the screen. Let me say, let's just say like welcome to linear regression, right? Welcome to linear regression. Okay, I can say /n for next line, backward /n for next line. Okay, now let's see again, let's start training the model, right? It sounds good, right? So I can say let's start training the model. Okay, again I'm going to put backward /n for next line and semicolon at the end to terminate my statement. Okay, one is we're having a bunch of printf statement, but it's for good user interface. Okay, so I'm going to say what number of graph points do you want to have, right? So based on the points the user have inputs, like the number of points. Remember from our demo we were plotting various points, right? So we want now the user to input the number of points they want. So I can say what number of points do you have, right? Let's say question, so I'm going to put question mark, then /n for next line. Okay, so after that I'm going to end with my semicolon, and we can now scan f to receive the value, right? So I'm going to say scan f %zd. Why? Because since I'm using unsigned integer type here, you can see I have size c, which is for unsigned integer type. I'm going to use %d for unsigned values, and from there I'm going to say comma ampersand train size, right? So again, this train size is to collect the number of that I can say the number of data points, right? So from there now we are going to store now the input in the size, in the train size. I don't know whether you get the point. Okay, so next we are going to declare our dynamic data storage variables, right? So I'm going to say double x, or it's going to be an array, so train size. So this is going to be like the array to store the x and y coordinates of the training data, right? Now that's for x, do for y, and just again train size. I forgot semicolon here. Okay, now we continue, and what we need to do now is to collect the training data points, right? And to do that, we just have to, in fact, let's also print f statement, and we are going to say now, comma, enter continuous values in the form, right? How does it sound? Yeah, so it sounds good. So continuous, how do you spell continuous? Is U-O-U-S. I hope it's correctly. Continuously, enter continuously values, right, in the form. Okay, in the form I'm going to be of x and y. Okay, so I think it sounds cool like this. Now we're going to again make it more formatted, so I will say you will enter this number of like, just to be more precise, right? I'll say you will enter this let me put the number of train lines of train size, right? You enter percentage ZT, right, of them, so that the user knows whatsoever they're doing. Okay, the number of lines they are to, the number of train size they are to enter. Okay, so after that, comma, I can now say train size, then semicolon at the end. Okay, now what next are we supposed to do? We need now like a for loop counter, right, that will a loop that will collect the each point, right, based on the number of train size the user enters. So to do that, I'm going to say for I, because remember this I will declare up as a loop counter, right? So I from 0, comma, I'm going to say I less than train size, right, then I plus plus. So in here now we can now say print f enter point, this just based on the number of points, right? So I'm going to say enter point percentage ZT, right? To make for good performance, and then put a hash here, so it will be like hash number this, so enter point this. So in here now I'm going to say comma, and I'm going to put the number, right, the first number. So since I started from 0, I'm going to say I plus 1. So it will say enter first number, enter point this number, or like that, iterating. Okay, so after that we end on semicolon, and we can now ask now the user to input it by using the scan function. So scan f, and I'm going to say percentage ZF. Now since we are entering how can I put it, we are entering the train size, now we are going to enter the values and store it in the array. Since they were double, I'm going to use LF, right, since it's a floating point, right? So LF, comma, I'm going to say again percentage LF. Now in here I'm going to say ampersand x of I hope the x is not capital, that's normal x of I. Now comma again, I'm going to say ampersand y of I again. I think we should be good here. Okay, now coming out of the loop now. So basically I hope you guys get the point of what is happening here. So basically inside here we prompt the user to enter the data points in form xy, right, and the loop now goes through and collect each point now to store it in the x and y values corresponding in the array, right? Okay, so let's move on the next step is for us to initialize the model parameters, right? And to do that, we're going to say double gradient, right? Gradient is going to be equal to, we're going to give a default value of 1.0 comma, then the intercept is going to be equal to 0.0. That's going to be default value. Now, so what happens here? We initialize the slope, that's the gradient, and the y-intercept of the line, right, with default values. Okay, now the next thing now is to train the configuration. So what we'll do now, we need to do that. I hope you guys are seeing it well. Let me scroll down. Okay, so what we need to do now is to say printf, and we need to ask the user, like, for how many epochs should we train, right? Now what does it do? So we need to get the number of training iterations, right? So we're going to name it epochs. Okay, so to get the number of training iterations, we first all need to say printf, and we'll say for how many epochs, right? For how many epochs, right, should we train? It's a question, right? Now the default that we're going to put is going to be 500. That is 500 iterations slash n for next line. Okay, and that's semicolon. Okay, after that, now we need to declare again another unsigned integer epochs. Okay, like this. Okay, now after doing that, we need to enter it, right? Get the user to scan F to enter the value of number of iteration, which we name it as epochs. So again, percentage z g, right? Now all of this needs to be inside quotes. So percentage zd, sorry, okay, comma, I'm going to say ampersand epochs. Okay, the number, this is going to be the number of iterations. Alright, now end with a semicolon, and the next thing now is we need to get, so if the user wants to get the default value, then they will input 0. So we need to have an if statement to check if the number of epochs, right, is equal to 0. If that being the case, then we let epochs equals to 500, since we set this our default value. So I can comment is out as, let me see, default value. Okay, now let me scroll again so that you see what I'm doing. Okay, I hope it's okay like this. Okay, now after getting the default value, you need to print f, and you need to ask the user, like, you know, say what should be the learning rate, right? You need to get the learning rate. So here the learning rate, just like, for example, let me say learning rate is like the number of steps you should take, right? So let me say you want to, for like a real life example, if you are running so fast to stop somewhere at a particular line, then if you run too much, you might as well bypass the line. But if you run slowly, you will like slowly just stop at the line exactly. So the learning rate here of our model, if you put it high, it's going to be fast, but and also dangerous. But if you make it slow, if you put it a lower value, it's going to be slow but more precise. So you get the point. So to do that, we're going to say printf to get the learning rate, right? So I would say what should be the learning rate of the model. So I can say what should be the learning rate of the model. So it's going to be a question Alright, now from this learn rate, now there's going to be a default value for our learn rate. So our default value for it is going to be just 0.011, right? Then slash n for next line. Now semicolon. Okay, now we need to declare now our learn rate. So I'm going to say learn rate. Okay, semicolon. Now next, now I'm going to get the user to put in that learn rate since we asked for it, right? So I'm going to be percentage LF since it's a double. Now here, comma, I'm going to put ampersand learn rate, then semicolon. Okay, now for since we said the default value is going to be 0.01, so if the user input 0, that means the 0 is going to be the default value, right? So if learn rate equals to 0, right, it's going to be the default value, and we say that the default value for learn rate is going to be 0.01. okay, so I can comment it out as default value. Okay, now so what actually, like, what's happening here? So here we just we get the number of training iteration, which is the epochs, right, from the user. Now we get it, we set the default. If the user enters 0, the default of epochs is going to be 500, and we also get the learning rate. If the user inputs 0, the default, we are going to take the default, which is 0.01. Alright, I hope it's understood here so far. Okay, next we are going to get now our login info configuration. So to do that, we need to declare signed integer unsigned integer, which is going to be log epochs price, okay, equals to going to be epochs divided by 100. Okay, now so this is going to to calculate the interval for login progress, right? And it's going to be in every 1% of the total epochs. Okay, so now the chain here is where the main logic goes in, now the training loop. So now our comment here, let me just say I can put here training loop. Okay, so in the training loop we are going to have it's going to be a nested for loop. The outer loop is going to iterate through the training epochs, while the inner loop is going to process each training example. Okay, get the point? So means this for size epoch, right? Since we did not declare epoch without, this one is going to be without s. So for size epoch equals to 0, comma, I'm going to say if the epoch is 1, if it's strictly less than, the epochs with this one with s, then our epoch, we increment it by 1, right? Epoch plus plus. Now in our before our inner loop, we need to declare now another variable, going to be a double sum. So I'm going to do sum errors, we're going to be equal to 0. Okay, now after that, now we need to get our inner for loop, which is going to handle the process, like we're going to process each training example. Get the point? So for when we I remember we already declared this I for counter loop, right? So for I equals to 0, I strictly less than the train size, right? I'm going to say I plus plus. Now inside the it, now let me just comment, since here's where the main logic is going to happen. So our the main thing here is that y is going to be, or should I put just small y? So the equation of a line will have mx, right, plus c. Okay, so here is the equation of a line there, just to comment how the form look like. So the first thing we're going to do is we're going to say double y guess, right? I'm going to say equals to gradient times x of I, right, plus now the intercept. So the intercept, that's c value. Okay, semicolon. Okay, so what happens here is that it finds the difference with the actual value, right? So the difference is going to be compared with the actual value. Now next, we need to do again double, and in this time we're going to have error. So the error is going to be equals to this y guess, right, minus the y, this value in the array. So we're going to get the error. Since I told you guys we are going to find out the difference with the actual value, right? So we need to take the error, which is going to be the y guess, and the y guess is the gradient plus the gradient times this x point, the point at the x point, and we add it to the intercepts, making now our error, since we want the difference from the actual value with the real value, right? So our error is going to be this y guess minus the y point, the coordinate, right, of the y coordinate. Okay, so after that, now if this our error, right, if this error is equals to 0, right, we're going to say continue, meaning, so if the error is like I'm gonna say untrackable, right, if it accumulates to an absolute, if you get an absolute error, so we're going to take the overall loss, right? So we're going to just say continue. Okay, now the next step, now we're going to try now to get the sum of errors. So I'm going to say sum errors going to be plus equals to the learn rate, right, times the x coordinate times the error, right? Okay, now what we need to do now is to improve the gradient. And I think first we were supposed to, yes, it's true, here we first say sum. That's a mistake, so this is going to be sum sorry, so sum is going to be, remember we used the math.h library, so it's going to be fact and error, right, to get a non-negative value. Now we need to improve now the gradient, and to improve our gradient we need to take the gradient. So gradient equals to, the gradient now is going to be this learn rate times the x coordinate times the error. Now we need to improve now the intercept, sorry. So to improve this intercept, I'm going to say intercept. So intercept is going to be equals to, I'm going to say negative equals to, even say same here to improve. Voila. Okay, so we're going to minus it. So we're going to be like minus the learn rate, right, times the error. Okay, we end with a semicolon. Okay, so everything, like, let me just explain what is going on here. And now some of you guys are confused, so I'm just going to mark this out. Okay, so what's going on here, right? Exactly. So in this we have our outer loop which iterates through the, where's my mouse? So here we have our outer loop which iterates through the training epochs, right? Now we have the inner loop, and in the inner loop process each training example, right? Now it then calculates the y value using the current model, that is this y equals to mx plus c, right? Now after that, now it computes now the error as difference between the prediction and the actual value, right? And here's it. And from there we move on and we skip the adjustment. If error is 0, then no correction is needed, right? So if error is 0, then we skip, right? And next we adjust the gradient slope based on the error and learning rate. So the gradient slope is going to be this based on the learning rate, and also we adjust the intercept based on the error learning rate. Okay, I think we need to continue from here. Okay, now after that, now let's come out from our loops. Okay, so to move along we need to we go in for the progress logging, right? So if this our epoch like mode log epoch, right, if it's equals to 0, then we do this. I think there should not even be need for me to put it in curly brackets, since it's an if step I can still do it like this. So if epoch log modulo log epoch, that means if they remain, if you take the epoch divided by the log epoch, if the remainder gives you 0, then you print. I'm going to print this statement. So I'm going to say epoch it lost, like epoch number this lost with this number is going to give the equation is of y, or like it's going to give the equation of y based on the epoch and the loss, right? So the loss is going to be the gradient, while the loss is going to be the epoch, and this other, in fact let me just write it down so that will be more clear to you. So I'm going to say epoch percentage ZD, right, comma, loss is, let's say, percentage 0.4 for decimal places, then LF, right, equation is y equals to, so what we are trying to do here is like we're going to print the progress every after 1% of epochs, and it's going to show the current epoch, the total loss, and the current equation. So you get the point. So we're going to be y percentage dot 2 into 2 decimal places LF x, right, plus percentage dot 2 LF, then slash n for next line. Okay, I'm going to end this with semicolon. Now we need now to include, now since we declare these variables inside, we need to call it after this. So the first one is going to be the error, right? So like when you say epoch, once we will like the epoch, this epoch plus 1, since it started from 0, epoch plus 1, comma, and we're going to some errors. So the second the value, which is in 4 decimal places, is going to be some errors again, comma, the gradient. So the value beside the x value is the gradient, comma, and we're going to have the intercept. Okay, so without any further ado, let's continue. I hope everything is on smoothly. So again, it just prints the progress every after 1% of epochs, right? So it shows the current epochs, the total loss, and the current equation. Okay, without any further ado, let's continue. I'm just making sure that my record screen is still going on, because I feel like the recording is stopped. Okay, I think it's recording. So to continue, we have already that we are almost getting done. So we need to like the early stopping condition, right? So we need to stop the training if errors get very small, just to indicate the model has converged to a solution. You get the point? So if some errors, right, is strictly less than, let me say, a very small value like 0.000001, right? How many zeros are there in total? Anyway, it doesn't matter. But if it's too small, right, we need to do this. You need to say printf. You can put something like stopping the chain, the model, because the error reduced a lot, right? So if the errors get so small, you need to indicate the model has converged to a solution. So I can say stopping to train the model, right? Model, because the error, right, reduce a lot. I don't know why my machine is freezing. Okay, a lot. This is going to be spaced out. I'll have no idea. Okay, so I'm going to say semicolon to end the statement. Now break. So I need to stop that if the model is training. If the error gets very small, we need to indicate the model has converged to a solution. Okay, and now we are still in the if statement. Then we come out from there. Let me scroll my screen so that it's becoming clear. Okay, so we need to do now final result. So in our final result, we say printf, right? Put our quotes. You can say the equation of the line is y equals to percentage dot 2lf x, right, plus percentage dot, let me say, into 2 decimal places lf, right? Now I'm going to say comma, the first one beside x is the gradient, and after that the c variable is the intercept, right? So after that I close my semicolon. Okay, now after that I just have to, I think, let's return my statement, which is okay. I hope there are no errors. We just have to compile and run. Control B to compile and run. Okay, there are errors. Let's take our time and debug. Okay, error break statement not within the loop. Breaks. So if printf equation of a line this. Okay, now here the same. If percentage log epoch, right, is equal to 0, and say printf this, and let's say error epoch undeclared. Epoch undeclared. I thought we declared epoch, right? Oh, it's not declared. It's kind of strange. I'm sure we declared epoch somewhere. Let me see if it's like epoch is not declared. Okay. Oh, there are some errors up here. Okay, so I say expected expression before this. So we have percentage d this scan f, percentage lf, percentage this is okay. I see the problem here. Was supposed to be ampersand. Okay, and in here again ampersand is this here that they say epoch will not define. It's kind of strange. Let me see. But epoch is defined up here in the training model, right? So let me see. The epoch is not defined. Okay. Epoch undeclared variable. Use this function. Did not mean epochs. Okay. Hello, very well. Epoch long epochs. Epoch goes you're going to say if epoch. Okay, let me compile again. At least the other errors are gone. Let me take my time and okay, let me drag this point. Okay, we have error in line, that's line 59, which is if epoch log this epoch, so it's going to be if epochs. I'm not actually seeing the error. 0. So if epoch log this 4, let me see whether 4, but here is defined here. Size t epoch, again epoch to epochs. So if epoch less than this, how come that is epoch was not defined? And we got the value from here. Let me see. We have the debugging is taking lots of time, but this is normal. So let me see again. We have up here for size epoch equals to epoch less than epochs. So it is defined here. Now, after it's been defined, what next? If so, okay. So log equals to 0. We have print epoch log this. What's the other error saying? Break statement not within the loop. So here, okay, so okay. It's like I see the main problem. all of this was supposed to be inside the loop. Then we rotate Ctrl X and put it here. Alright, see there's an error in the loop. Then we compile again. Wow, it ran because it was not inside the loop. Here's a compile code here. Okay, let me try and run it. Let me open my terminal here. So if I say ls, I'll see the output. So dot main.c, just main. Okay, it says what number of points do you want to plot? Let me just say 2. Now I said enter. Okay, so if I say let me see 2, 5, now enter now on 3, let me say 7. For how many epochs, I'll put 0 as a default, again 0 as a default. Okay, so you can actually see how it's actually here, how the model work, right, predicting right to the perfect fit, right? So it's like you see, it's a epoch 1 loss is this equation y equals to this, so it's like predicting right to the perfect fit up to those number of iterations of, that's the epochs, right, to the form where it found line is y equals to this. I think we should not test it. Let me run this game engine so that we test it and see whether it works perfectly, but fine. Okay, so for example, if I have some value, like let me put here and maybe here. Okay, so here is showing that the value there. Let me load it fast. Okay, you see calculating. So the equation of the line is y equals to 0.75608, like that. You see calculating plus x length plus 0.082. So there we have the point 0.41, 0.339. So I can actually test those points. Let me test it. Let me first clear my screen. So if I rerun the program, and I have two values, right? So the first one was 0. First one was 0.41, 0. I think was 39, right? Let me see. Okay, 0.41, 0.39, and the second one is negative 0.49, 0.30, negative 0.49. So new one is negative 0.49, 0.3. Is negative 0.30. Okay, so I'm going to increase the number of epochs here. Let me say 10,000. Okay, 10,000. And again, like I said, that if you input the learning rate to be small, it's going to take more time and be more accurate. But if it's bigger, it will be fast and less accurate. So I'm going to reduce it to 0.001 and I press enter. Okay, what do we have here? We have our prediction model as y. The equation of line equals to y equals to 0.77 x plus 0.06. Okay, let's see the prediction from the model from this. Okay, see, we are actually correct because it's right at almost there, but it's exactly there. So we have y equals to 0.765x plus 0.08. let me see, we have 0.07. okay, you just round it up, so you can see that the model works perfectly fine. Yeah, that was it. It was awesome, and I'll provide the code in the link below, and if you want that we should actually use the game engine, the gamma game engine that I talk about, created by my friend, to actually produce this visual, the graphical UI, right? Then just comment below, I will be there. So let me just end this video.